What's going on, guys? Paul here. Welcome back to another Cardano video. So today we get to look at Cardano scaling, where we are, what's coming in June, and what long-term we can expect as well. So I am delighted to have Isaac back. I've had Isaac on before, and I also have Morgan here today as well to give you more insight, because these are the guys that have the technical understanding of what's going on. So very welcome, guys. I do appreciate your time for coming on.
Great to be here.
Yeah, great to be here, Paul.
So we'll jump straight in and let you guys give an introduction to who you are or where ye sit in this whole big picture. So Isaac, do you want to start? We did have that call before about EUTXOs last year, which went down very well. So I'll let you start off there.
Yeah, hi. My name is Isaac Shapira. I'm the principal at Platonic Systems, a Haskell consultancy specializing in Cardano.
Hi, I'm Morgan Thomas. I am a consultant at Platonic Systems. Currently, my role is leading the team for Orbis, Orbis being the ZK rollup layer 2 solution for Cardano that we're working on. And by we, I mean Orbis Labs, which is founded by Ryan Matovu.
Yep.
Great. Yeah, I've actually had Ryan on probably a month ago now or something like that to talk about Orbis, so we can get into Orbis and this as well. I will put a link to that interview below for anyone who wants to see it. Morgan done a real deep dive paper on the EUTXO model last year, I think that was, and I'll put a link to that below as well for people who want to dive into that. But in terms of where we are now, there's a lot of excitement around what June is going to bring, Hydra, the SIPs that are going to be there, pipelining, all these different terms. Where do you think we're going to stand in June, or what do you think is going to be, what's going to be good for the chain coming out of June?
Yeah, so there's a number of things coming to the chain, right? And we already have, there's Hydra, which is a scaling solution. We've got the CIPs coming. Those should have an impact on scaling, and we kind of want to go through what to expect from each of those. So Morgan, do you want to talk a little bit about what Hydra is?
Yeah, so Hydra is a layer 2 scaling solution for Cardano, which IOHK is working on. Hydra is based on a concept of isomorphic state channels. Essentially, the idea here is that you get together with some other market participants who you'd like to do transactions with, and you lock some inputs, some money or state data on the chain into a state channel. And a state channel is kind of like a side chain. It's a ledger. It's like a decentralized ledger protocol, but it's not a fully general purpose one. It sort of piggybacks on the main chain to derive its security properties. It doesn't use like a full, consensus algorithm that can stand on its own the way that the main chain does. So what this gives you is a channel where you can do transactions with that fixed set of market participants who created the channel, if you yourself are one of them. I would compare it to the Lightning Network in Bitcoin. It's very similar to that.
I've talked to a number of people, including the leaders of other projects, and most people with a real technical grounding seem to think that it's not going to be like flipping a switch. It's not going to be like we get Hydra and all of a sudden everything is really fast. Protocols are going to take time to integrate with it. What kind of things do you expect us to see from Hydra in like the near term?
Right. So yeah, when Hydra launches, that's not going to immediately improve anything, because in order for a DApp to use Hydra, it has to be specifically coded to use Hydra. So like, we can see like performance gains for those applications that are coded to use Hydra, which are only going to be those applications that can use Hydra. Hydra is not going to work for every use case.
Right. Hydra, not all code on Cardano, not all Cardano dApps necessarily benefit from Hydra, right? So like some of them can take advantage of this additional functionality and some of them can't. So, like for example, I've heard things like a high volume trading pair could potentially be inside a Hydra head, and you could get a better performance. What do you have any other examples of things that you think might benefit?
Well, anything where the set of participants is fixed, like, if you're, I don't know, if you're playing like, a betting game with your friends and you're trading money back and forth, like that could be a good use case for a Hydra head. You can play your game and keep everything recorded on a ledger without having to slowly and expensively update the main chain. But like for a high volume trading pair, like that is getting into, in my opinion, the territory where Hydra doesn't work so well. Because the thing about a trading pair is that you want an open-ended set of participants, right? You want anybody to be able to walk up and interact with the trading pair. And that's not how Hydra heads work. Now, there are ways around this, like you can use a sort of a middleman type of protocol, but then that adds more layers of complexity, maybe less decentralization, security issues. So I wouldn't consider that to be a great use case for Hydra, in my opinion.
Okay, that makes sense.
So if I summarize this, let me know if I understand it right. It's Hydra is like a temporary layer 2 solution. You open it up with your set number of participants. You can trade, do whatever within that Hydra head, and then that has to be closed. Once you close that, we call it the temporary layer 2 gets closed, and everything is rolled up or everything is settled on the main chain then, is it?
Yep, that's the idea.
That's right.
So
it's got some limitations with what you can do in a Hydra head. Like you can't do minting in a Hydra head. Some of these things that you could do in like a normal Pluto smart contract.
Okay. I suppose if they could bring something like that in longer term, potentially what we see with these big NFT drops, there could be some use cases there where everyone trying to mint is part of the Hydra head, and then you can try and do your NFT drop there. Or maybe that's something that can be down the line. But it's like anything, when new tech comes out, we don't know the full possibilities of it. I think even from hearing the team talking and other fairly knowledgeable individuals out there, they're looking forward to seeing what the potential of this is going to be, that it's not going to be, like you say, day one a switch and everything works. It'll have potential to be built on top of and explore what it can do longer term.
Yeah, absolutely.
So,
that's like, I would be kind of hesitant to say call it a temporary layer 2. It may be ephemeral because you open it and then you close it, but it's going to have use cases long term. There's room here for use cases for multiple layer 2 solutions.
Okay, so sticking on June then, and other things that are going to come in the June hard fork. And if anyone hasn't heard, the temporary date seems to be the 29th of June that we're hoping to get it. And it's not going to be everything launches that day and then the day after protocols all have the new upgrades and everything like that. But some of the upgrades we're going to get, and ones that I'm really looking forward to, are the SIPs, these 3 SIPs that are meant to be coming out. Do you want to get into kind of an overview of what they are, what they're going to do? Because you both have connections to Ardana, and Ardana is one of the protocols that's definitely going to benefit from these.
Yeah, absolutely. Do you want to share your screen and we'll go through the 3 SIPs?
Okay, so I'll bring up the SIPs here now. You should be able to see that. These are the three SIPs that most people are talking about right now.
Yep.
So do you want to go through them, kind of what they actually mean for the chain or for the performance?
So SIP 31 reference inputs. This is a SIP to mitigate issues of UTXO contention. So in the extended UTXO model, when you're making a transaction, all of the most of the data that gets applied to it comes from the UTXOs, which you provide as inputs. And so those can contain some combination of currency and information. This is how dApps get their state. Like when you have a smart contract that relies on the state of a contract, then that's provided in the UTXO, that state.
Right.
And so one of the other properties of this model is that each UTXO can only be consumed once. And so the pattern is a transaction will consume a UTXO containing state, and it will output a new UTXO that replaces the old one that has the possibly updated state. This works well for some use cases, but not others. The use cases where this doesn't work so well are the use cases where you have a piece of information that is read a lot more than it's written. So an example of this would be an oracle, such as a price oracle. Like a piece of state on the blockchain that records the current price of Cardano in US dollars. That would be an example of a price oracle. Well, each time the price needs to be updated, that UTXO needs to be consumed and then replaced on the chain. But also, each time a smart contract needs to depend on that price, the UTXO needs to be consumed and replaced. And so that limits the number of simultaneous transactions going on that could rely on that state to one. So this makes it very challenging to build something like a price oracle, a scalable price oracle on Cardano. CIP31 reference inputs will simply provide a new type of UTXO or way of using a UTXO rather, where you are not consuming it, and for you it's read only. So that, will be really helpful for building things like price oracles. And that'll really increase the viability of the platform overall, in my opinion.
Can I restate and see if I understand?
Yes.
So it sounds like you want to publish some piece of data, right? Like in the case of the price oracle.
Mm-hmm.
And right now, publishing it means only one person can read it because it consumes the UTXO. Okay. Yeah, that's obviously a problem. And if this is a resolution to that problem, by providing a read-only UTXO that you can't modify so that everyone can read the same UTXO without consuming it. Is that accurate?
Yeah, that's accurate.
Okay.
It's going to solve the problem, and yeah, that's a big deal.
Yeah, that's huge. That's huge, actually. Okay.
Yeah,
so,
even
moving
for
on to
even for transactions, like it will remove a lot of transactions, unnecessary transactions, in a way that keep having to use that and putting through a transaction each time, which I know we have cheaper fees on Cardano, but even that gets expensive if you have to keep using the UTXO and creating a transaction to update something.
Right, and you have to copy it as well, right? That data's got to move from one UTXO to another if you didn't modify the state.
Yeah, well, I believe, right, like you'll still have to use a transaction when you need to update the state, but yeah, you don't need to consume and produce it when you're just reading the state. And like that, I'm not sure that will actually help with the amount of space that the transactions take up, because maybe the input is still recorded in the transaction. I'm not sure how that works, but the problem it'll definitely solve is this resource contention issue where you couldn't have two transactions at the same time reading the same piece of state.
Right.
Yeah, I suppose it'll be CIP33 that will really improve the resources and taking up space when you don't have to include the script in every transaction.
Well, yeah, that's a good segue into CIP33. So like one of the major causes of Cardano's throughput woes right now is that there is this design decision in Cardano that every transaction needs to include the full like compiled binary code for each of the scripts that needs to be run in order to validate that transaction. And so like say with a DEX, like every time there's a trade done on the DEX, the code for validating a trade is going to be added again redundantly to the chain. And so when you combine this issue with the very stringent limitations on the sizes of transactions and blocks in Cardano, it creates a situation where many apps effectively cannot be written on the layer one. Because the complexity of the requirements is such that the code to express those requirements will not fit within like the 16 kilobyte limit of how big a transaction can be. Like this script sharing CIP will not solve 100% of that issue. What it will do is make it so that we don't have to redundantly include the same code for the script again and again. We can just record it on the chain once and then subsequently refer to it. So that will make most of the transactions smaller. The part of this problem I'm pointing to that will remain unsolved with this CIP is that it will not increase the maximum size of a script. And so there are still going to be programs which are too complex to really code on Cardano right now.
I believe this also helps with like inter-protocol contention, right? Like if you have this very large script attached to a UTXO, and like you were mentioning the small the block size requirements, with being able to refer to a script, then you can have more protocols running at the same time without each one taking up such a large portion of the block.
Right, exactly. So there's a 64 kilobyte block size limit, or I think they increased it to 72 recently or something like that. But like that has to be shared. That, 72 kilobytes per block, 3 blocks per minute is all of the information throughput that the blockchain has that everybody in the world has to share. That's not a lot. Like that's a tiny fraction of the data throughput of my, DSL connection. It's really, really a very stringent limitation, which is required by the assumptions of Cardano's security proofs. And so anything we can do to, loosen that knot is important.
Yeah, it's not just the security proofs. It's also needed for Cardano's decentralization goals, right? Cardano nodes need to be able to run on limited hardware. They can't be something that requires like a giant beefy piece of hardware to run. So it's good that we have to live within these constraints for the long-term health of the chain and decentralization in general. But being able to refer to a script means many, many more transactions can fit on a block from protocols with complex logic. Where right now, if you have multiple protocols with complex logic, very few of them can fit into a single block.
Right. Yeah. So like I think best case, like with CIP33, we might see like 10x throughput increase of the chain. Again, best case, roughly speaking. That would depend on dApps being coded to make use of this feature. So we wouldn't see any of that immediately. We might not see any of that. Like we might not see any increase in the like total smart contract throughput of the chain, because there are also other limiting factors to consider, namely the per block computation and memory usage limits, which may actually be in practice more stringent than the code size limits implied by the transaction size limits.
Right. That said, I at the very least am the most excited about CIP33. Of everything that's coming right now, I think this is the one that's going to have the biggest impact on the ecosystem in the near term, and has the highest potential to kind of get things moving faster the soonest.
So I'm gonna like express a slightly different opinion. I think CIP33 is necessary for those outcomes, but may not be sufficient. That's what I'm trying to say.
Oh, very fair. But I am curious about what kind of difficulty you see in applications taking advantage of these new CIPs. Like how many months of effort roughly might you expect for an application to adopt these so that we can start seeing benefits?
Well, I haven't been shown the APIs, but just imagining what it would probably be like. I would imagine it would take very little effort to make use of CIP33. Could be done in a matter of days. The reference inputs, making use of that, I would also imagine would not be terribly complicated. Like in a couple weeks, probably a relatively complex script could be retooled to use that. Probably less than that. I'm being conservative.
Makes sense.
Yeah, I suppose just on the block size, I think we're now at something like 80 kilobytes, which is still very small. There's another upgrade coming either at the end of the epoch tonight or the next one. I'm not sure which one it is, but again, it's going up again. And the memory units, they seem to be doing increases on that all the time as well. And I suppose they all have to tie in together, all of these with the script sharing. When you look at the way the blocks on Cardano have changed over the last few months since we started to get these DApps, the majority, I think over 90% a lot of the time of transactions are smart contract transactions. So they're taking up a huge amount of space. So when you can pull the scripts out of that, it definitely does leave a lot more throughput there on the network. So in terms of other things coming, I think we're also getting, if I scroll down through this article here, this was all about scaling. We're also getting pipelining and input endorsers. Do you want to touch on that at all? What they are or what they might bring?
Well, sure. So these are like consensus protocol level improvements, and I can't speak to the specifics as I am not a consensus protocol engineer. But I can tell you that the expectation is that these changes will improve the throughput of the chain. And so I do expect that. And like, I don't expect it to be a game changer. Like, I think we're probably looking at incremental improvements here as opposed to all of a sudden the chain's going to be 100 times faster.
I think a lot of these work together. They all help each other in that when blocks are being propagated faster across the network with pipelining and everything there, that means that you can have slightly bigger blocks, more memory units. So again, they can all tie in together and give better throughput overall. So that's kind of June. That summarizes what we're going to get in June. After that, after June, there's also what you guys are working on with Orbis. So I have had Ryan on before to talk about Orbis, but do you want to talk about what Orbis is or what layer, I suppose start off what layer 2 solutions are. Some people think, why do you need layer 2 solutions? But the throughput, no matter how much you bulk the block size and everything like that on a layer 1, not everything needs to go through a layer 1 solution. So do you want to talk about what a layer 2 is? And then we'll get into Orbis and different types, how they can work.
Isaac, do you want to take this one? What is a layer 2 solution?
Sure. So essentially, the core contention in blockchain with performance has to do with consensus, and the more nodes that need to be involved in consensus, the slower it's going to be to achieve that consensus. That's an essential complexity. That's just part of the way consensus works. The more nodes you have, the longer it takes to achieve that consensus. There's also computational limits on what's needed to achieve a consensus. This is why when you see, blockchains that are really fast, a lot of times they have very beefy hardware requirements for nodes, as well as very few nodes involved in achieving consensus, right? Cardano philosophically is more rigorous here, and so wants to be very, very decentralized, which means lots of nodes are ultimately going to be needed to achieve consensus, right? And there's limits on how fast that can be. So what do we do when we say we want to have a lot of nodes, and the more nodes we have, the slower the throughput of the chain will be? This is where layer 2s come in. If you think about blockchain in general, it's really an ecosystem. And there's different actors and roles that things can play within the system that make the system work as a whole. Layer 2 is just another such actor, right? The role of layer 2 is to be a subsystem with fewer actors involved in achieving consensus, and can therefore achieve consensus much faster, have a much higher throughput. So if we can trust these small subgroups of nodes to achieve a consensus, then those participating in the layer 2 solution, if they trust those nodes, which is going to be in some ways less trustworthy or less decentralized than the layer 1, then those involved in that layer 2 can push the data to layer 1 where it can be validated by the broader group, right? And so with this, we can get better transaction throughput. If we want to be decentralized and we want to have lots and lots of nodes to achieve consensus, we can't expect that system to be fast. And that's going to be the layer 1. the purpose of layer 2 is to add throughput to layer 1 by having smaller numbers of actors achieve a consensus. That's kind of my core thought as to layer 2s and the way layers 2s work and why they're necessary. If you want to have a really fast layer 1, you're not decentralized and you're not realizing the benefits of blockchain from like an ideological perspective, right? Layer 1 needs to be allowed to be somewhat slower in order to achieve good decentralization. But we also want to replace the global financial system with something better. And that means that we have to have transaction throughput that can compete. And so that necessitates the presence of layer 2s.
On that, with Orbis, where does Orbis fit in? How does Orbis interact with Cardano? I know you use rollups, but can you actually explain first what rollups are, how that syncs back to the main chain?
Yeah, so Orbis is a layer 2 solution for Cardano. It's a ZK rollup. What is a rollup? Essentially, it's a ledger that exists off chain. So it's a ledger that is not maintained by a consensus algorithm. And so then the question for rollups is, if the integrity of the ledger is not maintained by a consensus algorithm, how is it maintained? And ZK rollups are like one style of answer to this question, where the integrity of the rollup, the integrity of that ledger is maintained using ZK snarks.
Okay. Well, let's maybe back up a little bit and just say, what is a zero knowledge proof and what is its purpose? Like, what benefit does it provide us with? Like, I definitely like to hear about, that it's concise and some of those properties. Like, there's a reason why zero knowledge proofs can provide this in an elegant way.
Well, right. So a ZK snark, that's an acronym. It stands for Zero Knowledge Succinct Non-Interactive Argument of Knowledge. Let's break that down. So what is meant by an argument of knowledge is what is meant by a proof. So a proof in this context doesn't mean like a proof in math where it uses the rules of logical inference, and provided that the premises you start from are true, the conclusion is guaranteed to be true. That's not what we're talking about here. What we're talking about is what's called probabilistically checkable proofs, meaning a proof is a witness to some statement being true, where if you have that proof, it tells you that it is highly unlikely that the statement to be proven is not true. And highly unlikely here is interpreted, within cryptography math as like, you have some security parameter where if you keep upping that parameter, that probability keeps going down and down, and it goes down fast enough that you can say it's converging to zero. So as your security parameter approaches infinity, your probability of your proof being wrong converges to zero. So that's what we mean by a probabilistically checkable proof. So ZK snarks are one type of those, and they have the property of being non-interactive, which means that a ZK snark is a single message. Like, you can record it as a sequence of bytes, whereas you can also prove something to someone by like having some interaction with them, playing some game with them. That's not what we're talking about here. They're single message proofs, non-interactive, and they're succinct, meaning, in other words, they're short. The number of bytes required to express them is small, like, maybe less than a few kilobytes. So those are all of the properties of the defining properties of ZK snarks, except for zero knowledge. And the zero knowledge part is whatever statement the ZK snark is supposed to be proving, nothing else is entailed by having that ZK snark, no additional knowledge except that which is logically entailed by the statement to be proven.
Right. And so this has kind of some weird and interesting properties, right? You can have a small thing in memory, the concise bit, right? You have this one representation of the ZK snark, of the zero knowledge proof, that can prove basically a very large number of statements. So with the rollup, we can continue to add more statements to the proof and prove all of them without in the same message. So this is a very odd property that this particular piece of cryptography has. You can take essentially an extremely large, I hesitate to say infinite because I'll probably be wrong, but an extremely large series of statements and have a single fixed size proof that can prove all of those statements at the same time.
Yep, that's the idea. And so how does this apply to making a rollup secure? Well, what you do is as you're building the rollup, you're creating a ZK snark that proves that that rollup is valid, that every transaction in it satisfies all the rules of the system. So if you have a copy of the rollup, right? If you have a copy of the ledger and you have that ZK snark, you can check that the rollup is valid. But then the trick is you need to agree on what is the current state of the rollup. So like we assume we have some, valid agreed upon rollup, and then we want to add some transactions to it. Who gets to decide, what is going to be the next block essentially? And so ultimately the agreement on what was the next block is recorded on the blockchain. Like whatever is recorded on the blockchain is it's definitive. It's the source of truth about, what is the agreed upon state of the rollup so far. So like you would record, say, a hash of the ledger together with the ZK snark proving, there exists a valid rollup with this hash. And then that is telling you what is the current state of the rollup, right? If you have it and you have the hash, then you can know that's the current state. That makes sense?
Yeah, and I suppose on the zero knowledge part, that's why we see some privacy protocols using this type of technology as well, because you can make all the transactions. There doesn't have to be the history of the transactions, but it can prove that the transaction was valid, but doesn't even have to have the details of the transaction. So stuff like that will be possible on Orbis as well. There's going to be many different use cases. From looking at it, what I've seen, I'm looking forward to seeing L3s and L4s and stuff like that coming into play. I know that's a little bit down the line, but individual applications or enterprises can come in and have their own layer on top of this, and it all eventually rolls back and has the security of the main Cardano chain as well.
Yep, that's the idea. Just to make one thing clear, Orbis does not intend to be a private ledger. So like Zcash, they're a private ledger, right? Orbis, the idea is more like it is with Bitcoin, where you have a public ledger. Everyone can see the transaction history, the addresses associated. But if people don't know that the address is you, then they can't tie that to you. This seems like a nice compromise to me personally, between like users' privacy on the one hand, but also like the needs of law enforcement on the other hand, who can maybe, if they need to, tie an address to a person and trace the transactions. I just think that type of system is more likely to remain legal in more countries in the future.
Yeah, you see the thing talking about how all illegal stuff happens on Bitcoin and stuff like that, but people who understand it know that it's probably the worst place you can actually do something illegal, because every transaction is traceable and eventually the funds come out into fiat somewhere. So you can start tracing back through that and find out what actually happened or who actually took the funds. So I know there's different mixers and all this, but I would say the majority of it is still able to be tracked nowadays.
If you want to do money laundering on Bitcoin, it happens at the fiat layer, not the Bitcoin layer. Yep.
So I notice we're running up the time here, and there is one thing that I have not discussed yet that I would like to discuss, which is comparing Orbis to other ZK rollup solutions. So like comparing to Hydra, we can say like Orbis is more general purpose, right? All of those use cases that Hydra won't work for, Orbis will work for them. But it actually, this is something that came to my attention recently, has a lot more potential than the ZK rollups for Ethereum for sort of a technical reason that I am going to share with you now. The Ethereum rollups are all using the Ethereum virtual machine, the EVM, which is like the model of computation of Ethereum. And this is a sequential model of computation. So the idea is that each smart contract script has to run on the EVM one after another, because the EVM has a global state that all of the smart contracts can access and modify. And so like if you switch around the order or if you run them in parallel, you can easily get a different result. And so that's why they all have to be run in sequence one after another. And what that means is that your ability to break down the work into small chunks is severely limited. You can contrast this with the EUTXO model, where there is no global state. And so in our research on scaling Orbis, we designed a strategy for scaling the ZK snark proving process to essentially any imaginable extent. You can like break down a block that needs to be validated into subsets and break those subsets down into subsets and keep going until you have small enough buckets of transactions that you can give one bucket to one computer and it can produce a ZK snark to validate those transactions fairly quickly. You get all those ZK snarks for all the buckets, and you start merging them together in a tree-like pattern. And so what that gives you is a way to scale the rollup sublinearly in terms of the proving time for the number of transactions. So like, say if you could validate 100 transactions in 10 milliseconds, let's say, then you could do 1,000 in 15 milliseconds maybe, and 10,000 in 20 milliseconds, and 100,000 in 25 milliseconds, right? That's a really nice form of scalability. And that works because Cardano has this stateless model of computation. You can't do that in any way that I am aware of with the Ethereum virtual machine. And so that's why their rollups are running on these massive computers, because they have to do it all on one computer. And with those massive computers that probably cost $100,000 a piece, they still won't be able to scale as much as Orbis can on commodity hardware, because they can't distribute the problem as much.
That's
nice.
amazing.
Yeah, I really like that. And that's actually something we probably forgot to mention. I discussed it with Ryan when I had him on, that this is built in the EUTXO model as well. It is built with Plutus, is it, and Haskell, and it's the same as Cardano essentially, unlike other layer 2s and stuff like that might be EVM compatible. So again, it could have lots of potential going forward for interactions.
Yeah, this is really a Cardano specific layer 2. And we're taking advantage of functional programming, of course, and this is one of those things where functional programming immutability allows exploitation of parallelism. And we see this pattern all across the software industry, where if you have immutability, you can exploit greater parallelism. And it sounds like in this case with the layer 2, by being able to, because Cardano is to the core immutable, and in this way, we can distribute the problem massively and get that parallelism back. So as far as I'm concerned, Ethereum layer 2 solutions and EVM solutions will never be able to catch up to Orbis in terms of scalability and throughput. It'll never happen.
I don't see how they could do it. They'd have to totally change their model of computation to do it.
Yeah, they would have to rewrite Ethereum to be Cardano.
I think that's a nice little snippet that I might take out and put that up onto social media as an intro to this video. that 60 seconds by the two of you there. But I realize time is rolling on now. You are busy. Is there anything else we haven't touched on here that you want to add in before we finish up?
I think I'm good.
Platonic Systems is hiring. If you like writing Plutus code and want to come write Plutus code with us, we are here for you. And if you want like writing Nix code, we are here for you too.
Also, if you
Great.
happen to be a ZK Snark researcher looking for a job, that would be nice too.
Absolutely.
These are highly sought after skills right now.
Absolutely.
So look, I just on that, on Platonic, I can put a link down below if you send me if there's applications or links to any of that, or what way you want people to contact you, let me know and I'll put that in the description. So
Yeah.
I really do appreciate you guys taking the time to come on. I've learned a lot. I hope everyone watching this has as well. Anyone that has, please do share this out. Let people know what's going on here and what's going to be longer term game as well. It's not all about the next few weeks. This is what Cardano is about, is building for the long-term future. So Morgan, Isaac, I really appreciate it. Thanks very much for coming on.
Pleasure speaking with you all and to you all.
Cheers.
Thanks. And maybe later on in the year, we can connect up again after the June hard fork, something like that. See how this is all playing out.